Here 16 cm long chord is drawn. AB is 16 centimeter. Here AB equals 16 centimeter, OA equal 10 centimeter, and OM equal what? If as we have drawn in this way, is given the chord is 16 centimeter, radius is 10 centimeter, then we have to find the value of or the distance of the chord from the center. Now dear students, we know OM is perpendicular to AB, and the first theorem we have to remember. The statement of first theorem is perpendicular drawn from center to chord bisects the chord. Then AM equal EMB is perpendicular drawn from center to the chord bisects the chord. Yeah. So AM equal 8 centimeter, OA equal 10 centimeter, and OM equal what? We know OM is a right angle triangle. So OA square equal AM square plus OM square using Pythagoras theorem. I think everybody's know. Or OA square is 10 square equal AM is 8 square plus OM square. 100 minus 64 equal OM square, or OM square equal 36, OM equal to 6. Therefore, the perpendicular distance of the chord equal 6 centimeter. In this way, we can prove or we can solve this question. In this figure 5a number we are discussing, here I have taken OC. I have drawn by a dot line. OC is 10 centimeter, that is radius of the circle. ON and ON perpendicular to CD chord and OM perpendicular to AB chords are drawn. CN equal 8 centimeter is perpendicular drawn from center to chord bisects the chord. Bisects the chord. That's why this is 8 centimeter. Now in triangle OCN, OC square equal ON square plus CN square. This is 100 equal ON square equal ON square plus 64. That is 84 is 60. 80 square is 64. Therefore, by solving this, you will get ON equal 6 centimeter. Again, this is 6 centimeter. That's why OM is also 6 centimeter. The reason is equal chords are equidistant. Equal chords are equidistant. from the center of the circle. That's why OM is also 6 centimeter. and and these they are bisected each other in perpendicular and opposite angle. This is also now OMPN is a square. The reason is this angle is 90. Two adjacent sides are equal. Angle between them is, this is also 6, this is 90, this is 90, and this angle already given 90, so next should be 90. Yeah, and at least two adjacent sides are equal and three angles are 90-degree given, so that should be a square. Dear students, once again I will repeat. These two chords are intersected at 90-degree. These two are perpendicular. That in the quadrilateral OMPN, next angle should be 90-degree. All angle 90 and at least two adjacent sides are equal. That's why it is a square. You have to claim in that way. Or the next angle should be 90. That's why all angle 90 and at least one pair of adjacent sides are equal. That's why that is a square you have to claim. And we know, finally we know, OP equal diagonal of the square OMPN, diagonal of the square OMPN. So OP equal L root 2 equal, the side is given 6 root 2 centimeter. In this way we can find the solution of this question. Now dear students, we have to write the given. This is question number 6A, page number 231. What is given here? Simply O is the center of the circle. O is the center of the circle. AD and BC are two equal chords. Intersected at A. This is first. Then to prove, dear student, angle OEB equal angle OED. OEB equal OED. That's why EO will be the angle bisector. Now 3 number construction. From here, if we have drawn perpendicular, this is M, this is N. Draw OM perpendicular to AD and ON perpendicular to CB. Now phone number proof statements regions. Now first of all I will highlight the solution of this. Angle M and angle N are 90-90. As OM perpendicular to AD and ON perpendicular to CB. So one is R. OE equal to OE, that is common side, H. And OM equal ON, that is equal chords are equidistant from the center. So these two triangles NEO and MEO are congruent by RHS axiom. And finally these two angles are equal. They are the corresponding angles of congruent triangle. That's why OE is the angle bisector of OED. In this way you can prove. Here you can add OE is the angle bisector of angle BD. Now dear students, in first number, in triangle NOE and triangle MOE, A number, angle ENO equal angle EMO. The reason for 1A is by construction. By construction, both are 90 degree. And B number, side OE equal OE, that is common side. This represents R, this represents H. And the third one is ON equal OM. This represents side. It means OM equal ON. Why are they equal? Equal chords are equidistant from the center. Number 2, triangle NOE is similar, congruent to triangle MOE by RHS axiom. And number 3, now this angle and this angle are equal. One angle is OEN, or that is B, and another is OED. So firstly, one more step you can write. Angle OEN O mm, we have to represent this angle, that is OEN. Yes, OEN equal OEM corresponding angles of congruent triangles. Therefore OE be equal to angle OED from statement 3. From here we have taken this relation because those angles are the same. Therefore OE is the angle bisector of angle BD from statement 4. In this way we can prove this theorem. Question number 7a, number 231. In this part we have to show triangle OAB is an isosceles triangle. For that, dear students, write the given first. Here we have given O is the center of the circle. And AC equal to DB or BD. AC equal BD. We have given two equal side, then O is the center of the circle. Now to prove, dear student, triangle OAB is an isosceles triangle. We have to prove this. Now 3 number construction. So let's join this. Join OC and OD. Number 4, proof. First one is statements and second one is reason. Now dear students, we have to show ACO and ODB triangles are congruent. If you can prove these two triangles are congruent, then this angle and these angles are corresponding angles of congruent triangle. We can write that. Then OAB is an isosceles triangle. We can claim that. So before starting that, OC and OD are equally given because they are the radii of the same circle, and these two sides are given equal, but we don't know this angle, whether these angles are equal or not. So we should show these two angles are equal first with the help of OCD triangle. Then side angle side axiom we can apply. Then we can prove this theorem. So number 1, dear student, in triangle OCD, angle OCD equal angle ODC. The reason is these two angles are equal. Why are they equal? These two are equal because OCD is the OC and OD are of same circle and triangle OCD is an isosceles triangle. The reason behind this is this. Number 2, ACO and BDO, we have to show they are equal. So I think they are also the exterior angle of isosceles triangle are also equal. Outside exterior angle of this, yeah, this to this, but we will be proving 180 minus this angle equal to this, and angle ACO equal 180 degree minus angle OCD, and angle BDO equal 180 degree minus ODC, this point is the sum of angles, the sum of ADJ, ACE and the adjacent angles in a straight line is 180 degree. These two are adjacent angle in a straight line. These two are adjacent angle in a straight line. This part is done in this way. And number 3, angle ACO equal 180 minus ODC. ODC equal angle BDO. That OCD is replaced by ODC. This is from statement 1 and 2. These two are equal, we found. Now in triangle ACO and triangle BDO, ACO and BDO, for number A, AC equal BD, AC equal BD, that is given. Number B, angle ACO equal angle BDO from statement 3, and OC equal OD, that is radii of the same circle. Now dear students, therefore 5 number, therefore triangle ACO is congruent with triangle BDO. The reason is by side angle side. This is side, this is an angle, and this is side. Yes, axiom. And 6 number, what to prove? Let's check what to prove. Yes, we have shown this too. Now A and B angles equal, we have to show. Then ABC is an isosceles triangle, we have to prove. OAB is an isosceles triangle. Now angle OAC equal to OBD. angle OAC equal angle OBD. This is corresponding angles of congruent triangles. Triangle OAB is an isosceles triangle, that is from statement 6 is base angles are equal. Proved. In this way we can prove this theorem. Shortly I will tell the way. The same question, 7a number question. Yes, I have already proved. Now I am repeating it by another method. If the construction part is, if we have drawn the perpendicular to this chord CD, then the name that OM is perpendicular to CD or AB is drawn. CD is best option. So if we have drawn the perpendicular, then what will you get? CM equal EMD, that is perpendicular done from center to chord bisects the chord, that's why they are equal, first part. And you can add AC in this side and plus DB in this side, then the result is AM equal EMB. These two are equal due to the perpendicular drawn from center to chord bisects the chord. AC and DB are given equal. AC plus CM is AM. MD plus DB is BM or MB. Now in triangle OAB, in whole triangle OAB, not in whole triangle OAB, OAM, in triangle OAM and OBM. In OAM and OBM, simply this side is equal, this is 90, this side is common side. Simply AM equal EMB, that is from these statements. And second is angle M equal angle M, that is both are 90 by construction. And third one is OM equal OM, that is common side. So these two triangles are congruent by side angle side axiom, and these two angles are corresponding angles of congruent triangle, that's why OAB is an isosceles. Firstly, draw the figure in this way, dear students. And here AB and AC are two chords meeting at a point A. Angle BAO and angle CAO are given equal, or OAB and OAC are given equal. Then we need to prove AB equal to AC. So the given is, firstly we will write given O is the center of the circle. O is the center of the circle. Angle OAB equal angle OAC. This is given. And angle this equal to this. O is the center of the circle and angle OAB equal to angle OAC. OAB equal OAC, that is given. Now 2 number to prove, we need to prove the chord AB equal to chord AC. We need to prove these two chords are equal. Now we need construction, dear students. Construction is from here draw perpendicular and name is M, and here draw also perpendicular and give the name N. Construction is draw OM perpendicular to AB and ON perpendicular to AC. Now 4 is proof. Here we will write statements, and in this side regions. Firstly, in one number, in triangle OAM, OAM and OAN, OAM and OAN, these two triangles, in these two triangles, a number angle OMA equal angle ONA. One number region A is by construction. OMA, ONA by construction, both are 90 degree. By construction, both are 90 degrees, so they are equal. And second case, angle OAB, angle OAB equal to angle OAC, OAC, that means angle OAM equal to angle OAN. OAB is OAM, OAC is OAN. That's why I have written this. That means this is given. Angle OAB and angle OAM are the same angles. That's why in the same points or the statement I have written. That means OAM, OAB is OAM and OAC is OAN, which is already given. Now third number statement is OA equal OA, OA equal OA. The region is common side, common side. Therefore, triangle OAM, congruent triangle OAN, this is by AAS facts. Now after this, number 3, dear students, OM equal ON, OM equal to OM, that's the region is corresponding sides of congruent triangles. And number 4, AB equal AC, the region is OM and ON are perpendicular and equal. That's why equal AB and AC are equal is equal chords are equidistance, equal chords are equidistance from the center of the circle. In this way we prove these theorems. I think you understand this. Now in 8th, dear students, we have given a circle. AB and AC are two equal chords. O is the center of circle. Then we need to prove OB equal to OAC. First of all, let's write the given. O is the center of the circle. O is the center of the circle, and AB and AC are equal chords, or AB equal to AC you can write. We need to prove angle OAB equal angle OAC. We need to prove these two triangles are equal. These triangles are equal. Now the construction. We need to draw the perpendicular line and here also draw OM perpendicular to AB and ON perpendicular to AC. Now prove this side is statements and this side region. In statement number 1, here also in these two triangles we have to compare. In triangle OMA 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 and triangle ONA. Number A, here these two angles are not given. We have to show that these both angles are 90. This is common side, and OM and ON are equal, is equal chords are equidistant from the center. So we can apply RHS axiom. Angle OMA equal angle ONA, 1A region. This is by construction. Both are 90 degree. And B number AO, this represents R, this represents H. B is common side, and C number OM equal ON, equal chords are equidistant from the center. Equal chords are equidistant from the center. of the circle. And number 2, triangle OMA congruent to triangle ONA. The region is by RHS congruency test. Now 3 number, angle, this angle OAM equal to angle OAN. That means angle OAB equal angle OAC. The region is corresponding angles of congruent triangle. In this way, we can prove this theorem. Now we have to solve this. This is question number 9. Here we have given PQ and RS are two chords of a circle. PQ equal here, PQ equal 16 centimeter. PQ equals 16 centimeter. And RS equal 23 cent. RS equal 30 centimeter. RS equal 30 centimeter, and MON equal 23 centimeter. Yeah, so we need to find the radius of the circle. The radius of the circle equal what? So now, dear students, let's join these two. That the construction, simply construction is join PO and RO. We know PM equal 8 centimeter, and because PQ is 16, that's why PM is 8 centimeter, and RN is equal 15 centimeter. The reason is perpendicular drawn from center to the course bisects the curve. Yeah. Now let OR equal OP equal R, that is radius of the circle. This is supposed by capital R. Oh, if that is the same name being, instead of that, we can suppose we have the same name, so let's change this. Radius of the circle, here is R given, so small r. Yes, I have supposed small r because capital R is already given. Radius of the circle is small r, I have supposed. Or anything you can suppose, that is the variable. And again let On equal x, On equal to x, and MO equal whole, this is 23, down one is x, so MO is 23 minus x. MON, the straight line MON, the length of MON is 23. ON is supposed by x, so MO is 23 whole, that is 23 minus x is MO. Now in triangle PMO, OP square equal PM square plus OM square equal, that means OP is R square equal PM is 8 square plus OM is, or MO is 23 minus x whole square. The equation is first. We made this first equation. Similarly, in triangle RNO, OR square equal RN square plus ON square. This is hypotenuse, this is base, this is perpendicular. That implies OR square is simply R square equal Rn square is 15 square plus On square is x square. This is equation second. Now equating both the equation, because in first equation this is the value of R square, in second also value of R square. Equating first and second, 8 square plus 23 minus x square equal 15 square plus x square, or simply the value of R square is putting the value of R square in first equation. You can understand in that way also. Anyway, they are comparing, both are the value of R square, that's why both are equal, we can suppose. So 8 square plus a minus b whole square, we have to apply 23 whole square minus 2 times 23 times x plus x square equal 15 square plus x square cancel. Then